Hello, Wenxiang Zhao here from Illinois Institute of Technology. This paper is related with GPS receiver, anti-jamming, and interference mitigation method. So my research is trying to develop a robust GPS receiver against wideband radio frequency interference, which may be broadcast by the GPS jammer. In this paper, we mainly focus on the carrier tracking because it's the weakness part during jamming events. So we build a Kalman filter model for doing this carrier phase and frequency estimation problem. And we have the clock phase dynamic model, and we have the measurement model based on the IQ samples. And it is the clock scenes that make the Kalman filter works under interference because the clock is quite robust. It won't be influenced by the interference at all. So the Kalman filter usually works for one certain model, but here we have uncertainties in navigation data bits. So we introduce a multiple model algorithm for solving this problem. Basically, we will run in two parallel Kalman filter on the top and bottom, corresponding to two hypotheses of the data bits. And we will combine the estimation result using the probability function. So we have an experimental test. We use the simulator generated RF signal, and we use the USRP to collect the data, and we're doing a post-processing use software-defined receivers. And here, a billion clock are for the satellites and receivers. And each different PRN has a different drop in character noise ratio as the interference events. So here are the results. On the left-hand side, the normal case, and on the right-hand side, the jamming case. And I'm plotting the carrier frequency estimation error versus the time. On the left-hand side, you can see the blue dot is the typical receiver phase lock loop. On the right dot is the MMKF. So it has a similar performance between each other in the normal case. And on the 15 dB Hertz jamming case, we can see that the PLL lose lock when the interference kicks in, but our MMKF can still provide a zero mean estimation error on the carrier frequency. So in the previous result, we assume we have no knowledge about data bits, but in the reality, the data bit has some meaning and we can do a prediction of it. So here is an example. We have the original frame in colors, 1500 bits. And on the right-hand side, the things in the color means we can predict it, and things in the gray means we cannot predict it. So we'll assist this information to the MMKF. And also on top of it, we're doing an IOD check to check if there's any new uploading of the ephemeris. And here the result, we improve the estimation error variance from 0.16 Hertz to 0.11 Hertz. So any questions, please reach me at this email address. Thanks.